This is the setup solution for problem number 59. So it says that I've got a box sitting on the truck, and the truck's going to accelerate away, and the box is supposed to stay on the back of the truck. And the goal is to find the coefficient of friction that'll keep the box on the truck. So this is what it would look like. Truck moves away, box would drop down. That's what we don't want. We want to keep the box on the truck. So I've got to have enough force to do that. So what force exists between the box and the truck that can move the box to the right with the truck? Well, that force is going to be friction. So this is the one time that the friction is going to be supplying the net force to keep it in that keep it moving. Usually friction always opposes the motion, and it's still opposing the motion between the box and the surface, but from the observer sitting outside, what that friction is going to do is it's going to accelerate the box in the direction of the net force. So if I look at the box, it's got a surface when it's sitting on the truck, so that's normal force and mg. Normal force going up, mg going down, and then friction is what's going to be pushing the box to the right to keep it on the back of the truck. Our net force is also going to the right, because if it stays on the back of the truck, we'll see the box accelerating to the right. So the force accelerating the box is the frictional force, and the only time that could be a possibility is whenever friction is the only force you have in the same direction as the net force. So if I'm summing up the forces in the x direction, it is accelerating in the x direction. That's equal to ma net. So that's going to equal to all the forces going in the same direction as ma net, which in this case is friction. Summing up the forces in the y direction, it's not accelerating in the y direction, so that's equal to 0. And that's going to be equal to eta minus mg. And that's your basic setup. Next step would be to define friction. F is equal to mu times eta, and then solve for mu.